Thank you for joining me today. We're going to be talking about how to find the mean of a data set. So let's quickly remind you of what the mean is. Again, you may know it as the average, but when we're talking about measures of central tendency, it's called the mean, which is simply the average of a set of data. Again, to find the mean, what you will do is take all of the data set, all the numbers in the data set, add them up, okay, and then divide by the total number that you had. So we're going to take a look at a couple of examples to show you how that's done. All right, so the first one here, we're looking at 6 numbers. Okay, the first thing you have to do, of course, is take those 6 numbers and add them up. So my suggestion would be to just line them up vertically. And I'm always going to put the top number, or the largest number, on top with the most digits, and then everything else below. So it doesn't really matter the order. That's just a preference of mine. It doesn't have to be a preference of yours. But I'm going to list these out. And let's see, I'm just kind of marking them off as I go so I don't double up, because when you're dealing with multiple data sets, it is very easy and quick to make a mistake and add one extra of a number. All right, so we're going to just start here on the right side, 0 and 8. And what you can look to do is look for those compatible numbers that make 10, because that's just going to make things like 8 and 2, 6 and 4, that's going to make your addition a little easier. So you notice here I have 8 and 2 at the bottom. I can go ahead and add those. That's 10. If I add 6 and 5, 6 to 10, that's 16. And then 16 plus 5 is going to give me 21. And then 21 plus 8 is going to give me 29. So that means put my 9 at the bottom, and I need to carry the 2. Now when I carry that 2, you can see quickly I can combine it with that 8 to make 10 again. So that's 10, 17. 17 and 9 is going to give you 26. 26 and 9 is going to give you 35. And 35 and 7 is going to give you 42. So carry the 4. And then 4 plus 1 is going to give you 5. So 529 is the value that we're dealing with. And now I'm going to count up all of my values that I started with. That's 1, 2, 3, 4, 5, and 6. So I need to do some division. How many times 6 goes into 529? All right, so because 6 can't go into 5, I need to figure out how many times 6 goes into 52. And that's going to be 8 times, because 6 times 8 is 48. And then we subtract, and we get a difference of 4 there, and we bring down the 9. And how many times 6 goes into 49? That again is going to be 8, giving us 48. And because our directions say round to the nearest whole number if necessary, we should go ahead and do one more digit. So place your decimal and bring down a 0. All right, so at this point we're looking at, oops, I'm sorry, you got to subtract there, bring down the 0. And we're going to go ahead and see how many times 6 goes into 10. Well, that's only going to be once. So at this point, because we're rounding to the nearest whole number, since the 10th digit's a 1, which is below 4 or below, that means we need to just keep that number where it's at. So our average here, or our mean for this data set, would be 88. And it's always a good idea to look and make sure that that's going to make sense based on the numbers that you're dealing with. So I'm dealing with 88, 75, 96, 100, 92, and 78. So what that means is when I look at 88, does that make sense for those numbers to be the average? It should be within that range, and it most certainly is. So that seems to be a pretty good mean for that data set. You wouldn't want to have something like 130 or something really low like 50 or 60. That would raise some red flags. All right, so let's take a look at one more. This data set again, just a particular survey that was given. We're going to go ahead and do the exact same steps. So let's go ahead and line them up. They're all 2-digit numbers, so we can just line them up one over the next. So 28, 32, 56, 52, 18, 12, and 21. All right. So let's go down. We have actually a couple of 10s we can make. We have 8 and 2 here, which is 10. And we have 8 and 2 here, which is 20. And it gives us 20. So then 26, 28, 29. And I'll just write that off to the side. We're going to carry the 2. So we have 5 and 5, which is 10. 3 and 2, which is 15, 16, 17, and 4 more, 1, 2, 3, 4 at the bottom. So that's going to give you 21. So 219. All right. So we have, again, actually in this case we have 1, 2, 3, 4, 5, 6, 7 values that we need to divide. Let me make a little room here. So we're going to do 7 into 219. Let's see how many times that goes. All right, 7 goes into 21 3 times. All right, with nothing left over, so 7 goes into 9. We bring down that 9. 7 goes into 9 1 time. And again, I want us to round it to the nearest whole number. So let's take it out one more place. Bring down a 0. Add our decimal. 7 goes into 20 2 times. So we can stop there. And we can see that we'll just keep our mean or average at 31. We wouldn't round it up to 32 because that value of a 2 means to keep your whole number right where it's at. So the average for this set of data here would be 31. So again, analyze what you have there just to make sure this makes sense and that it's not way completely off base. 31 seems to fit in pretty well there, so it looks like we found a pretty decent average for this set of data. This has been a quick tutorial on how to find the mean. Thank you for joining me.